Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is erase and maximize. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You have with you n dice. Each die has 6 faces and the faces contain the value 1, 2, 3, 4, 5 or 6, one value per face. The orientation of the face does not matter in this problem. Now you are also given an integer s whose value goes from n to 6 times n. You must choose n integers x1, x2 till xn such that each of these values are between 1 and 6. Additionally, sum of all the numbers that we have chosen, the n numbers, must be equal to s. Now once we have chosen this, we must choose one face from each die such that the value of those faces chosen and their sum is equal to exactly s. So to give you an example, let's say our n is equal to 4 and s given is equal to 9. So in that case, here are our 4 dices that have 6 faces and we have turned them to a face in such a way that their sum is equal to 9. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 4 is equal to 9. Now once we have done this, what we'll do is for each face we must replace the value written on it to be equal to 0. So we will remove this 1, make it 0, remove this 2, make it 0, remove again this 2 and replace it with 0. Same goes for this 4. Now once we have done this, what we can do is we can again rearrange these dice in such a way that we get the maximum sum possible. So since this face has been now turned to 0, what is the other maximum face that I can rotate it to? Well, that will be 6. And this is the case for all 3 dice. Therefore, the total maximum value that we can get here is 24. Now, as per the given question, it is always guaranteed that with the n dice that we have, it is possible that to move them in such a way that or arrange them in such a way that the sum of their faces is always equal to s. And our task is to find this maximum sum that we can get after performing this operation. That is, first rearrange the faces in such a way that their sum is equal to s, then replace the selected faces with 0, then again rearrange the dices in a way to get the maximum sum. Now, for the input format, we have t test cases, and for each test case, we have two lines. We have one line that has two spaced integers n and s, and for the output, for each test case, we have to output the maximum possible score that we can obtain. As for the constraints, number of test cases will go from 1 to 1000, n will go from 2 to 100, and value of s will range from n to 6 times n. Let's see some sample inputs. So for the first sample input, we have two dice and the sum that we have to reach or the initial value of s is equal to 8. So we have two dice. Let's say we rotate them with face such they are 4 and 4. Now in this case, their sum is equal to 8. We will perform this step that is converting them into 0. Once we do that, each of the die will contain the following elements 1, 2, 3, 0, 5 and 6. Because remember, the face that we had here, we have converted it to 0. Now again we have to rearrange the dice in such a way that we get the maximum value possible. So since we want the maximum, we will rotate them to have 6. Now in this manner, the sum now is 12 and that is the maximum value here. Let's see how we can solve the second sample input. Now the second sample input has again two dice and the sum has to be 11. So let's say we keep the face 5 and 6. The sum is equal to 11. Now we will erase 5 and 6 from these dice. So this die will contain 1, 2, 3, 4, 0 and 6. And this one will contain 1, 2, 3, 4, 5 and 0. Now again we have to rearrange them in such a way that we get the maximum value possible. Now this first die can be converted or rotated to have a 6 here. But here we cannot do that. So we'll rotate it to whatever maximum we have, that is 5. And this also gives us 11. Therefore, that is the answer here. Let's see how we can approach the solution. So from the sample inputs, one thing that we have observed is that In the die, we have all these numbers, right? Let me just write them out. First, we have to sacrifice a number from each dice such that it contributes to the sum and we can reach S. Once that is done, one of these number, let's say the index vi, is going to be converted into 0 and we cannot use that. After that, this die will again be used to get the maximum sum possible. Now the best case scenario that we can have is that each of the dice have a 6 on it. That is the best case scenario. So if we go to the problem in the reverse manner, that is we want to get the maximum sum. For that, it is best if we have 6. Now if you want to get 6, it is ideal if the initial phase that we choose does not have any 6 on it. Now to do so, what we can do? We can use the next best, that is 5. So let's say if I put 5 on all the faces and the sum is greater than or equal to S. So if it is equal to S, then it is, well, it's just fine. But if it is not equal and it is greater than S, then it means that I can decrease the value of some other die and still reach S. Isn't that it? So to give you an example, let's say we have 8, the first example. If I put 5 on both the dice, the value is 10, but we don't want 10, right? We just want 8. So let's say we move it to 3. Now here, the face value sum is still 8, right? But I have not used my 6. It means now when I convert them to 0, right? I will change 5 and 3 to 0. Now 6 is still left in the dices. So now I can rotate them and I have 6 on both the sides. This will maximize my final score. But what happens if I have 11, right? Again, I have 2 dice, but I need to reach 11. Even if I have 5 on both, I still lack 1. So I need to convert one of the dice to 6, right? Now with this, we know that there is only one die that we will have 6, others will remain 5. So what we can do is, we can check we have n dice, we'll multiply it by 5. This gives us the max value that we want to have. We do not want to give 6 to our dice. And we will find out what is the difference from S. If this difference, if there exists, right? If this value is negative, it would mean that we need to sacrifice that many dice and have them as 6. So let's say we call this the difference, right? So whatever absolute value of difference is, those dice will definitely be sacrificed and 6 will not be present there. So the maximum that we can take from them is just 5. And whatever are the remaining dice, those are successful in preserving their 6, therefore we will get 6 from them. And this will be the maximum score that we can get. And once we print this, we'll have our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of n and s. Then we find the difference. That is, if we put 5 on all the dice faces, what is the value that we can get? If this value is greater than s, then it means that we can just adjust the others to have a lower value and keep the sum as s. This will preserve 6 in our indices when we erase the faces that currently we have to zeros. And with this, the answer will be nothing but 6 times n. But if that is not the case and 5 is not sufficient for s, then we'll get a difference. That is, these many dice we will have to change to 6 to fulfill the sum to be equal to s. So these are the dice where the maximum that we can get will remain 5. So that is difference into 5, and whatever is remaining, we can get a 6 here for our final score. We sum them up and we get the final result. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n and s, find the difference between if all the faces have 5 and the value of s. If this difference is positive, then it means that we can just adjust them and our maximum score is going to be nothing but 6 times n. But if that's not the case, then whatever is the difference, we will get the maximum 5 from those dice, and for remaining, we'll get 6. We'll sum them up and we'll get the final score. And that is also the maximum score. Therefore, I have AC in Python implementation as well. I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.